Okay, ma. So this is the given question. So find the mass defect, binding energy and binding energy per nucleon for a helium nucleus. Okay, ma. So mass of helium nucleus is given, mass of proton is also given, mass of neutron is also given. Okay. So first of all, can you say, how can I calculate mass defect, ma? Mass defect, how can I calculate? Mass defect. Mass defect means what? The amount of reduced energy, reduced mass. Clear, na, ma? So how can I calculate? So mass of individual nucleons, okay, ma, minus mass of helium nucleus. This is how I can calculate, na, ma? Mass of individual nucleons minus mass of helium nucleus. Because mass of individual nucleons is always greater when compared to mass of the nucleus. So that a difference of mass is nothing but mass defect, the mass which has converted into energy. Understood, no? So therefore, what is the mass of individual nucleons, ma? So helium nucleus he gave, no? In helium nucleus, how many protons will be there and how many neutrons will be there? Chapandi. 2 protons and 2 neutrons. So therefore, 2 into mass of proton plus 2 into mass of neutron minus mass of helium nucleus. This is what I have to do, no? So 2 times mass of proton is how much? Mass of proton is already given. How much, ma? 2 into 1.007277 plus 2 into mass of neutron. Mass of neutron is how much? 1.008666 minus of mass of helium nucleus. Mass of helium nucleus is already given. How much? 4.001509. Okay, ma? So if you do this calculation, first of all, I will get the mass defect. Understood, no? And I will write the mass defect, ma. So mass defect which he gave is 0.030377 atomic mass units. So this is the amount of mass which has disappeared when this helium nucleus was formed by combining 2 protons and 2 neutrons. Notes రాయడం పైన ఉన్నారా, వింటా ఉన్నారా ఏమన్నా? వినాలి. Okay, ba? This is the mass defect. So then what he is asking? Binding energy. Second one which he is asking is binding energy. Okay. Now can you say, how can I calculate binding energy, ma? Binding energy, how can I calculate? Anybody? Come on, mass defect I have calculated, the amount of mass which has disappeared. Now how can I calculate binding energy? Binding energy you can calculate by 2 methods. Either you can calculate by E is equal to mc square, okay, ma? Or already we have studied that if 1 AMU is converted into energy, it will release 931.5 million electron volts of energy. Already we have studied, no? If 1 AMU, if I can convert into energy, then how much energy will be released? This much amount of energy will be released. Now here also I got answer in terms of AMU only, no? Okay, so therefore substitute. So therefore, energy released, or you can call it as binding energy. Okay, ma? So binding energy is how much? How many AMUs have disappeared, ma? 0.030377 AMU has disappeared. And 1 AMU, if it is converted into energy, this much amount of energy will be released, no? So energy multiplied by mass multiplied by 931.5. Okay, so if you do this calculation, I will get binding energy. Okay, ma? And the answer which I gave is 28.3 million electron volts of binding energy is released. Are you able to understand? Okay, then what is the third question he is asking? Third question is BEN. What is meant by BEN? Binding energy per nucleon. Clear, nama? So BEN is nothing but binding energy divided by number of nucleons. So binding energy is how much? 28.3 million electron volts divided by how many nucleons are there in helium nucleus? 4 nucleons are present. So just to do this calculation, I will get the binding energy per each nucleon. Okay, ma? And the answer is 7.07 million electron volts. Okay, This is how we have to do the calculations. Okay, very easy. So here there is a graph given, graph between mass number and binding energy per nucleon. Clear number? On the x-axis, on x-axis mass number is given, and on the y-axis binding energy per nucleon is given. Okay. Then in which of the following processes energy will be released? That is when y converts into 2z, w converts into x plus z, w converts into 2y, x converts into y plus z. In which of these processes energy will be released? Okay. Now do you remember, I said energy will be released in which process? Energy will be released in which process? Energy release అవ్వాలంటే ఏం జరగాలి చెప్పండి. So I already said you know, so when atoms of lower BEN, when they convert into atoms of higher BEN, okay, then energy will be released. Already I said you know, then energy will be released. గుర్తుందా ఇది? Clear ma? When atoms of lower BEN, when they converts into atoms of higher BEN, then energy will be released. Because higher BEN means what? Binding energy is greater. Binding energy is greater means more energy is released. Are you able to understand now what is meant by binding energy? The mass has converted into energy and that energy is released. Okay. So if BEN is greater, atom is more stable. Already we discussed all these points. No? So when lower BEN converts into higher BEN, then energy will be released. Okay. Or you can say that, clear? This is one case. Or you can say that if total binding energy, okay ma, of products is greater, okay ma, then also energy is released. Okay. So when compared to reactants, if products binding energy is greater, it means more energy is released. And if more energy is released, atoms will be more stable. Understood? No? Now first you take the first reaction, first operation, y converts into 2z. So I will do this calculation, remaining 3 calculations you are supposed to do. Okay, now see, listen very carefully. Y converts to 2z. Now see where y is present, this is y, whose mass number is 60. And what is its binding energy? 8.5. Okay ma? Therefore, total binding energy of y is how much? BEN of y is 8.5. What is the binding energy per nucleon of y? 8.5. Then what is the total binding energy? That's all, 60 into 8.5. Mass number is nothing but number of nucleons, no? What is meant by mass number? Number of protons plus number of neutrons is nothing but mass number. Ante kada mass number ante. So therefore, how many nucleons are there in y? 60 nucleons are there. And what is the BEN for each nucleon? 8.5. Therefore, total binding energy is nothing but 60 multiplied by 8.5. So this is the binding energy of y, which is converted into 2z. Okay. Now calculate for z. So total binding energy of z. What is the atomic number of z? Sorry, mass number of z? 30. Clear, no? 30. And what is the BEN of z? 5. So 30 into 5 is how much, ma? 150. Are you able to understand? 150 million electron volts. Now you compare these two. 60 into 8.5 is bigger or 150 is bigger? 60 into 1.5. Do the calculation. 8.5 into or 85 into 6. So 8 6 are how much, ma? 48. 480, 5 6 are 30. So how much it is? 510 million electron volts. Clear? So therefore this value is 510 million electron volts. Okay. So binding energy of reactants is greater or binding energy of products is greater? Binding energy of reactants is greater, no? It means that higher BEN atom has converted into lower BEN. So energy will be released or absorbed? Energy will be absorbed. Energy will not be released. Okay. So therefore in this condition I can say that energy of reactant you cannot say, just you can call it as mother atom, is greater than energy of binding energy of daughter atoms. Okay, ma? So energy is not released. Which one, ma? 2z is given. Very good. 2z is given. No, we have done only for 1z. So therefore, for single z it is 150. For 2z it is how much? 150 into 2. So it is 300 million electron volts. Are you able to understand, ma? Even then also it is 510 and 300. So 510 is greater than 300. So energy is not released in this process, but energy should be absorbed in this process. Okay. Similarly, can you do 2, 3 and 4? Okay, ma? Do the calculation. So in which condition it is released? Okay, ma? So third one I have done. W tends to, W gives rise to 2y. So W atom, it is converted into 2y atoms. Okay, ma? So in this condition I see that binding energy of daughter atoms is greater than mother atom. So definitely here in this condition energy will be released. Understood, ma? Similarly, you do the remaining 2 calculations and see whether energy is released or absorbed. Second one is also energy is absorbed, correct? Fourth one also energy will be absorbed only. Only in third process energy is released. Okay, check it.